Hi guys, welcome to this class. Today we'll be looking at logarithm and indices, but we'll be focusing majorly on logarithm, on how to calculate our logs or evaluate our logs without using calculators and for figure tables. In our subsequent classes, we'll look at how to use for figure tables and calculators in calculating log. Now let's get into the basics of it. What is logarithm? Now, the log of a positive real number n to the base b is defined as the power to which it must be raised to obtain an n. That means if n has to be raised to power y, the log of n will be base b will be raised to power will be equals to its power. Now, let's look at our first example. It says find the value of x in the following. Now, our first question here, we have x equals log 381. Here, 81 is our n, our b is our 3, and x is the power to which it is raised. So here, we transform it to this form. Now, this will give us 3 raised to power x equals 81. Okay, where our n, like we said, n is 81, b is our base, and y is the power to which it is raised. Okay, so now this gives us 3 raised to power x equals 3 raised to power 4. Okay, so cancelling our bases here, x equals 4. All right, now to question 2. Question 2, we have it as 2 equals log x 16. Now, since x is our base, 2 is our power to which it is raised, and 16 is the number. So this becomes x raised to power 2 equals 16. Okay, and x raised to power 2 is 2 squared. So to find our value of 16, we'll do square root of both sides. So x equals square root of 16, which gives us 4. Alright, next we'll be looking at laws of logarithm. Now, we have log base an plus log a base an will give us log mn, log base amn. Now, since they have common log bases, our addition will turn to multiplication. That becomes log mn. Now, we have common bases as a. Log m minus log n will become log m divided by n. Log m raised to power n will become n log m. Okay, now log aa. Now, when you have same bases, your log is same as your base, it's equal to 1. Now log 1 is equals to 0, and log base m and n will be log m over log n. Now we are going to look at some examples in that. Now let's look at log 3 plus log 7. Now we assume that both are in common base, in same base, log 10. Now if we have this, example 1, if we have this is going to become, applying our first law, this becomes log 3 times 7, which will give us log 21. Okay, now having done that, the next one we are going to look at is number 2, our log 6 minus log 2, which will give us from here, applying our second law, which will be log 6 over 2, which gives us log 3. Okay, now our next one would be log 2 128. Okay, having log 2128, we have it as, now 128 will give us log 2 raised to power 2 raised to power 7. Okay, 2 raised to the power 7 will give us 128. So this, applying this law, this gives us 7 log 2. Now, bearing in mind that we said when we have log AA equals to 1, then our log 2 here equals 1. So this now gives us 7 as our answer, because this will be 7 times 1, which gives us 7 as our answer. Now, in our fourth example, we'll be looking at, okay, log 813. Okay, having log 813, this something as log 3 over log 81. Now, what's log 3? Log 3 all over log, changing this to base 3 will give us 3 raised to the power 4. Now, applying our law here, this becomes log 3 over 4 log 3. Now, log 3 will cancel out, leaving us with 1 over 4 as our answer. Alright, so our next set of questions, we have evaluate the following. Now, let's look at question 1. Evaluating question 1, we have log 75 plus log 9 minus log 243. Okay, now applying divided by log 20 minus log 12. Now applying our laws of logarithm, okay, our product law and division law, this becomes log 75 times 9 divided by 243 all over log 20 divided by 12. Okay, so from here we have it as 75 times 9, we have it as 675. This becomes log 675 divided by 243 all over log 20 over 12. Okay, so if we break this down, we are having it as log 25 over 9 divided by log, this is 5 over 3. 4 into 25, 4 into 12, 3. Okay, now this we divided with 27. 27 into this will give us 25, and 27 into 243 will give us 9. Okay, so from here we will now break this down to be log 5 raised to the power 2, 5 raised to the power 2 all over 3 raised to the power 2 divided by log 5 over 3. Now these are common, so we can bring it out as square. So this gives us log 5 over 3 square all over log 5 over 3. Now bringing our power down will be 2 log 5 over 3 all over log 5 over 3. Okay, so with this, we can cancel out this to give us our answer as 2. Okay, our next second question talks about log 2 5 over 8 plus 2 log 2 3 over 4 minus log 2 45 over 64. Now, the good thing is that they are all in same common basis or in same base. So this becomes log 5 over 8 times 3 over 4 all squared, okay, divided by 45 over 64. Alright, so from here we have it as log 2 bracket 5 over 8 times 9 over 16 times, doing our inverse will become 64 over 45. Alright, now with this we can now cancel out. Okay, 8 here, 1, 8 into 64, 8. 8 times 8 will give us 64. 9 here, this we can rewrite as log 2 raised to power minus 1, following our fractional indices law. So from here, we have minus 1 log 2. Okay, but log 2, but log 2 equals 1, considering our laws of indices. So minus 1, so therefore minus 1 times 1 will give us minus 1. So with this, we've solved our other examples, getting the answer as 2 and minus 1. If you've seen this video up to this moment and you've enjoyed our class, don't forget to subscribe and share the link with your friends. If there be any question, put it down in the comment section. Alright, looking at our next set of questions, we have log 8 base 2 minus log 27 base 81 minus 64 log 64 base 16. Now we are going to solve out these questions one at a time. Now starting with question 1, we have log 28 minus log 81/27 minus log 64 base 16. Now if we apply a change of base law to this question, okay, this becomes log 8 over log 2 minus log 27 over log 81 minus log 64 over log 16. Okay, so from here we can break this down to become log 2 raised to the power 3 all over log 2 minus log 3 raised to the power 3 all over log 3 raised to the power 4 minus log 2 raised to the power 6 all over 2 log 2 raised to the power 4. Okay, so from here we can now break this down again, as bringing it down we have it as 3 log 2 over log 2 minus 3 log 3 over 4 log 3 minus 6 log 2 over 4 log 2. So this cancels out, leaving us with 3 over 1 minus 3 over 4 minus 6 over 4. Okay, so from here we find our LCM. Our LCM will be 4. Okay, if we have our LCM as 4, this becomes 3 times 4, 1 here 4, 4 times 3, 12, minus 3 minus 6. So this will give us 12 minus 9. 12 minus 9 will give us 3 over 4. So our answer will be 3 over 4. That will be our answer. Now looking at question 2, we have it as log 10 4 plus log 10 25. Now remembering our laws that says that when they're in both in common basis, this becomes multiplication. So this becomes log 10 4 times 25. So this we have as log 10 100. Now 4 times 25 will give us 100. Now this we can break down to log 10 10 raised power 2. Okay, so this will now give us 2 log 10 10. But we know that log 10 10 is equals to, but log 10 10 equals 1. Okay, so this will now give us 2 times 1 to be 2. So our answer will be 2. Now looking at our third question, we have log 10 6 plus log 10 45 minus log 10 27. Now they are all in same basis of 10. So this will become log 10 6 times 45 addition, subtraction becomes division over 27. Okay, now 6 times 45 would give us 270. So this becomes log 10 270 over 27. Okay, now 270 divided by 27, 270 divided by 27 would give us 10. So this becomes log 10 10, and log 10 10 equals 1. So our answer would be 1. Our next set of questions says evaluate the following. Now, in evaluating this, we have our first question as log 3 4 and log 4 9. Alright, now for us to evaluate this, we will use our formula that says change of base formula. Our law that says change of base. This will become log 4 over log 3 times log 9 over log 4. Okay, so we can now break this down, and this and this. This becomes log 2 2 over log 3 times log 3 2 raised to power 2 over log 4, log 2 raised to power 2. Okay, so this will become 2 log 2 over log 3 times 2 log 3 over log 2 log 2. So log 3 we cancel log 3, log 2 we cancel log 2, leaving us with 2 times 2. 2 times 2 will give us 4. Okay, this can cancel this, so leaving us with 2 as our answer. Okay, so the next one we'll be looking at is log 27 over log 9. Okay, we can break this down to become log 3 raised to power 3 all over log 3 raised to power 2. Okay, having done this, the next thing we will do is to simplify it out. Okay, so in order to simplify it out, we'll be having it as 3 raised to power 3 log 3 over 2 log 3. Cancel, leaving us with 3 over 2 as our answer. That's for question 2. And for question 3, we have log 3 minus log 2 all over log 9 minus log 4. Okay, so the denominator, we can break it down to smaller logs, okay, which gives us which will now give us log 3 minus log 2 all over log 3 squared minus log 2 squared. Now remember that our minus becomes division. So this becomes log 3 over 2 all over log 3 squared over log 2 squared. But this, since they are both squared, we can write it to be log 3 over 2 all over log 3 over 2 all squared. Okay, so bringing our power down, this becomes log 3 over 2 all over 2 log 3 over 2. Okay, so this cancels out, leaving us with 1 over 2. And we know that 1 over 2 can be rewritten as 2 raised to power minus 1, but we can still leave it in this form. So with this, we've solved our question. Alright guys, with this, we've come to the end of today's class. If there be any questions or comments, don't hesitate to put them down in the comment section below. See you in our next class.